Hello everyone, my name is Atamofak Benes and I'll be presenting to you our project on enhancing machine learning precision through integrated gradient saliency applied in multi-class image classification models. Together with me in the team is Olatunji, Pierre, and Tata Elvis. Here's our workflow. What exactly is machine learning? Machine learning is a machine learning technique that enables us to remove the influence of specific data points efficiently and effectively while keeping the performance of the unlearned model accurate or unchanged on the remaining dataset. Why the need for machine learning? It is very necessary as there is a rising increase in the need for privacy issues, as well as the need to remove undesirable dataset or dataset influence on trained models. It is also very applicable in different tasks, including copyright protection. Now, naively, one could achieve this task by just simply retraining the entire model with the remaining dataset for which the forget set has been removed. But this comes with a lot of cost in terms of time as well as computational cost. And therefore, there is a need for an efficient and effective method of unlearning. What then defines an efficient and effective unlearning algorithm? This method should be able to effectively unlearn the model at a time very much less compared to retraining the entire model from scratch, as well as it should be able to perform very well on the retained data set. And also to a very much greater extent, it should be the online model should be able to remove the forget set, the desired forget set. And so there are existing machine unlearning algorithms, some of which include inference unlearning, random labeling, as well as fine tuning. But each of these algorithms comes with their limitation. And some of these limitations include instability and the inability to effectively work effectively on larger data set and larger models. And so to counter these limitations, unlearning using gradient saliency was introduced. This method introduces weight saliency during the unlearning process. These salient weight are actually obtained by derivating the loss of the forget set with respect to the model parameters. And now, because these derivations are done natively, it comes with limitations such as noise and instability during model differentiation, as well as sensitivity to input perturbations, and also poor performance for situations where the model doesn't show linear trend. And so to solve this issue, we introduce integrated gradient silencing method to enhance the generation of silencing weight. How does our approach work? So we assume a straight line path from a baseline input image to our original input image. A baseline image is an image for which the prediction will be zero tensors. And so we do a path integration from the baseline to the original input image. We pass this resulting value across a given threshold. And so for each gradient for which the threshold is met, that particular gradient is kept and used during unlearning to target specific input values. This reduces this is aimed at reducing time as well as cost of computation, as well as the cost in unlearning. And so here's our pipeline. So given an entire data set, we randomly pick out a sample for forgetting, and we pass in the on we pass the unlearn the model. We compute the derivative of model input parameters with respect to inputs with respect to model parameters, and then uh use that to use that for unlearning. And so to achieve this task, we use for our baseline model, we train a ResNet 80 model on Cypher 10, and we set aside 10% of the model randomly for our forget set. We measure the performance of our model using techniques like unlearning accuracy, which is defined as one minus the accuracy of the model on the forget set, testing accuracy, which measures the generalization ability of the model, as well as membership inference attack, which measures how well the model was able to forget the desired forget set. And so as seen on the table here, our model was able to surpass the saliency unlearning in terms of retained accuracy as well as test accuracy. And so for our future work, we intend to evaluate the performance of our model on larger data set as well as larger models, and also evaluate the performance of the model on different tasks aside image classification, tasks like image generation. And also to conclude, we've seen that our model was able to significantly perform better than existing models. Thank you.